Hello, everyone, and welcome back. This is Mr. Covalt, and in this video, we're going to go over nuclear decay series. So, in the last couple of videos that I've done, we went over um, nuclear reactions, type of nuclear reactions, how to write nuclear equations. And so here we're going to talk about what a nuclear decay series is. So a lot of times in nuclear reactions, reactions, things don't always decay in a single step, right? So we've been seeing one-step reactions where one atom or one isotope will decay into another isotope, and then that releases some sort of particle or energy. It often doesn't exactly occur in that single step. Usually, that single step is just one step in multiple steps, many steps in a series of steps. So sometimes, as it takes a lot of these little steps to reach a more stable isotope. So that's what's going on. Is why do certain isotopes decay? It's because they're unstable, right? We talked about how you have that um, band of stability, and depending on the ratio of your protons to neutrons, um, if you have too big of a nucleus, or maybe even too small of a nucleus, or not enough neutrons to create um, a stable nucleus, or maybe you have too many neutrons. So whatever the case may be, um, your nucleus is unstable, and so it will undergo decay in order to become to result in more stable isotopes. Oops. And so in a nuclear decay series, like what we saw earlier in another video, is you start off with what is called a parent isotope, so P1. Here's the beginning of our series. So we begin with P1, parent isotope number 1, and that will decay into daughter isotope number 1. So we have D for daughter, P for parent, plus you got some sort of radioactive particle. Either it's a beta particle, a alpha particle, a positron emission, or maybe it's gamma radiation. So something is released. So we saw various types of those type of nuclear reactions, different decay, different types of reactions. Um, so the parent number 1. So this number 1 parent decays into daughter product number 1. And then what's going to happen is that this is maybe the first step in a long series of steps. So then this daughter here, daughter 1, can now become the parent number 2. So the daughter isotope here in itself can then decay and become and then give rise to another isotope. So then it becomes the parent, and then then that parent number 2 then decays and produces daughter product number 2. So, and then so on and so forth. So so here you have daughter number 1, and daughter number 1 then becomes parent number 2, right? So parent number 1 gives rise to daughter number 1, and now daughter number 1 becomes parent number 2, meaning that it is going to now decay and give rise to another daughter isotope, plus some radioactive particle is emitted. So each time you get a decay, you get some sort of radioactive particle emitted. And then what happens is daughter 2 then becomes the third parent, and then this isotope will decay into another daughter isotope, and so on. And so you get this long step of series. So here's an example. So you can copy this down, right, as I'm going through it. And so here you have uranium, what is called uranium-238. These numbers are actually on the wrong sides. I don't know why they're there, but so you have uranium-238. It has 92 protons. Uranium, if you look uranium up on the periodic table, you'll see that it has 92 protons, 92, atomic number 92, and here its mass number is 238. So this is uranium-238. And so what's going to happen is that uranium-238 is going to undergo some sort of process, a decay process. And so it's going to become thorium-90 234. So you can pretty much figure out from the numbers what this particle is. So if you're going from 238 to 234, then you lost a mass number. You went decreasing the mass number by 4. So that means this particle has a mass number of 4. And you can see that it went from 92 to 90, so it lost an atomic number of 2. So there's atomic number 2. So 4 mass number 2 atomic number. So this means that this is an alpha particle. So this has gone under alpha radiation, alpha decay. So uranium-238 loses an alpha particle and becomes thorium-234. But then this element here now, so this is the parent isotope, and here's the daughter isotope. Now the daughter isotope here is undergo its own decay, and it produces another further isotope, so a daughter isotope. So this is daughter isotope number 2. And so you can see again from the numbers, this one is 234, but it stays 234. So whatever this particle is, its mass number is 0 because there's no change here. But you'll notice it goes from 90 to 91. So it gained a proton. So if you're thinking about the numbers, this particle here, in order to keep both sides equal, to keep this 90 and this 90, then this particle must have an atomic number, or that bottom number has to be a -1. So what particle has 0 for the top number and -1 for the bottom number? If you guess beta particle, you would be right. So this one undergoes beta decay. So you start with an alpha decay and then a beta decay. And so then here you can see now the next step, this daughter isotope now is a parent isotope, gives rise to this one, undergoes another decay. So it produces a third daughter isotope. And so here you can again figure out what the particle is. So you're going from 234 to 234. So again, 0 for the top number for the particle because there's no change here. So this particle, so these two particles here have to add up to this particle. So 234 plus 0 gives us 234. And this one we have 92 and this is 91. So 92 plus what gives us 91? Well, that's -1 again. So we got another beta particle being released. So here we have 2 beta decays in a row. So we have an alpha decay, beta decay, beta decay. And you can keep going on with this as we continue. So here you can see you have uranium-234. So we've gone from uranium-238, which is not that stable, to uranium-234, which is more stable. But still, uranium-234 is not perfectly stable because this is going to undergo another decay. So this is going to go from uranium-234 to thorium-30. So what particle is this? So we got 30 here. So we got thorium. What's the bottom number? Well, the bottom, if this is thorium and this is thorium, and the bottom number is the atomic number, and the atomic number tells you the identity of the element, so that means that this bottom number should be 92 since we have thorium. So thorium is number 90, but we have 230. So again, we go from 234 to 230, we lost 4. So that means that the top number of this particle is 4, and we went from 92 to 90, which means the bottom number lost a 2. So that means this particle must have top number 4, bottom number 2. So that, again, that's an alpha particle. So this has gone under alpha particle. So we have our 90 there. So that way we have an alpha particle. And so you can keep doing this. And so what I want you to do is I want you to continue filling this in. Pause the video. So go ahead and pause the video and just fill in the table, fill in the circles with the appropriate element, the appropriate numbers, and the appropriate particle that's being released. So just keep in mind that this symbol here is alpha, and this symbol here is beta. So fill in with the appropriate symbols, fill in the numbers that missing, and fill in what's missing for the element. So go ahead and pause the video, and then unpause the video, and then you'll see what the answer is. Okay, so let's see how well you did. So here it's radon. That's an alpha emission. So you go from 88, you're told 88, that's the atomic number. You look that up on the periodic table, it's radon. So then that must be 236 because this is an alpha particle, right? So here, this is releasing an alpha particle. You know it's probably going to be an alpha particle because you're going from 90 to 82. You lost 2. That's typical of an alpha particle. And so if you guess that it's an alpha particle, then that means you went from 230 to 226 because you lost 4. And then you keep going. So Rn, that's going to be radon, sorry. And so if you look that up on the periodic table, you know the atomic number is 6. And again, you're going from 88 to 86. So that indicates that you have an alpha particle being released. And so that means that the top number is going to lose 4 from the 226. So this should be 222. So now you have radon 222. And so you keep going. So another alpha emission, that means you lose 2 on the bottom. You got 218, you lost 4 on top. So we know that's alpha emission. And so what's number 84 on the periodic table? Polonium. And then here, lead, you have lead 82, you have 84, so you lost 2. Again, that's going to indicate alpha particle, and that means you lost 4 from the top, so that's going to be 214. And here, you gained 1, so you went from 82 to 83. That's typical of beta emission, so that's going to be beta. So you got a beta decay here, and so that means that the top number is not going to change, so that's going to be 214. And then here, you've going from 214, and then you've got this here. So we got to figure out what this is. So let's see. Here we know that this is 82, right? So we can skip this. Lead is number 82 on the periodic table. So now we know that we have 82 and 210, right? But notice here, we're going from 214 to 210 here. Okay, so maybe that might help us out here. So here, and we have 83, so this is going to be 214. and that's a beta decay. So that's 214 stays the same. That's typical of beta decay. So that means that the bottom number here should be 84. So that's going to be 84, which is polonium. And since this is 82 and we lost 2 from 84, that's going to be alpha. And then we just keep doing the exact same thing. So here, I'll just fill in the rest. And so that's what you should have. If you got that right, congratulations. Hopefully, if you didn't get it completely right, hopefully you understand your mistakes and won't make those mistakes again. Okay, so let's graph out the decay series. So what we're going to do now is the decay series that we just saw, the decay series that we just went over, and you have on your paper. We can show that on graph paper. So you can get graph paper and do this on graph paper with me. And I'll show you how this works. So on this graph paper, you'll notice that on the bottom, you have uh, your atomic number. So that's the number of protons. And you have your atomic mass. So this would be number of protons and neutrons. So here, we're kind of looking at how things are changing. So now we can take that series that we just saw, that we went through, and we can plot it here on the graph paper, right? So we'll see how that looks on the graph paper. So what's happening to the atomic mass of the isotope and what is happening to the atomic number as it goes through the decay series. Okay, so we're going to focus on this top part here. We're going to zoom in on here to make things clear. So let's get into this. So here's the zoomed in part. So we have our atomic numbers on the bottom and we have our atomic mass on the side. So again, we started with uranium. So here's our uranium. What you're going to do is we're going to put, what you typically do is you're going to put your element symbol in the box, right? So in the box here, that means 92. So uranium, we're starting with uranium that has 92 protons and a mass of 238. So this is uranium 238. Remember, you name it by the mass number. So this is uranium 238. And so now we can take the decay series that we just finished, because we have it in front of us. Now we can plot this on the graph. So what happened to uranium? Uranium went through alpha decay, right? So that means it loses 4 in mass, right? So the mass number goes down by 4, right? So if we look here, so the mass number is here at 238. So it undergoes alpha decay. So it's going to go down by 4. So 8, 7, 6, 5, 4. So now it's here in this mass, and it's going to decrease by 2. So notice that here it was at 92, and it decreases by 2. Now it's at 90 and 234. So this is where we're going to put our next element. So it undergoes alpha decay, and that's what we have, thorium, right? So thorium 234. So what's the next one? So thorium, what happened to thorium? It went under beta decay. So beta decay, remember, under beta decay, the mass number doesn't change, right? So the mass number doesn't change, so it's going to go this way because it gains a proton. So notice that alpha decay brings it down this way. You lose a mass number 4, and you lose a 2 in your atomic number. But then when you undergo beta decay, the mass number doesn't change, but you gain a proton. So you're going to stay in the row, and you move 1 to the right. So beta decay causes you to go to the right. So now you have this symbol, this element here, and then you do it again, right? So if we follow on the other sheet what we just plotted, So then the next time it's another beta decay. So again, we're going across to the right, staying in the same row, right? And so that's going to be another beta decay. The mass doesn't change, but the atomic number changes because the protons are changing. So we're gaining a proton each time we undergo beta decay. So when we gain a proton, we get our 2 protons back that we lost from the alpha decay, right? So we lost the 2 protons and we lost the mass of 4, but now we gain those 2 protons back, and now we have uranium-234. Okay, and then we can keep going. So you go ahead and plot this. So pause the video, follow the same pattern. So you've got the sheet in front of you now that we went through together. Now take that pattern and graph it following the exact same steps that I have just shown you. So pause the video, work on it when you're finished, and then I'll show you what it should look like. Okay, welcome back. So you finished, and so let's see how you did. So your graph paper should look like this, right? So here's where we stopped. And so we had a series of alpha decays, right? So each alpha decay, you lose 4, right? You go down 4 in mass, and you go over 2 in your atomic number. So you lose mass by 4 and you lose your atomic number by 2. And then you undergo another alpha decay. So you lose 4 in mass and you lose 2 in your atomic number, 2 protons. You lose again, so another alpha decay. So you lose 4 in mass, you lose 2 protons in your atomic number. And then you keep going. It's the same pattern. So 4 down in mass, 2 across in protons. So we're losing 2 protons. Lose 4 mass, lose 2 protons. So now we're at lead 214. And now we got a couple of beta decays. So remember, beta decay does not change the mass. So the mass stays the same, 214. We stay at 214. So you're just going across when you do a beta decay. So, and you gain a proton. So we're going back this way. So 1 beta decay, you get bismuth, and then that's 1 more proton. So now we're at 83. So here we're lead 82, or 82 for lead, and now we're at 83. Undergo another beta decay, and we gain another proton, and we're now at polonium. And now here we go undergo an alpha decay. So we lose 4 in mass, and we lose 2 in protons, in atomic number. So now we're back at lead, but now it's lead 210. And we undergo 2 beta decays. So beta decay, we're going to stay at the same mass, so 210. So, but we're going to gain a proton. We're going to lose that electron, and we're going to gain a proton. So lead becomes bismuth again, and then we lose another electron, and we gain a proton. So then we're back to polonium, but now it's polonium 210. And then finally, we're going to do one last alpha decay. So we lose 4 and we lose 2. So we lose 4 in mass, we lose 2 in our atomic number, and we end up with lead 206. And that's where the series stops. So this, ladies and gentlemen, is a good example of a decay series that is well known. Okay, so I hope you enjoyed this video. If you liked the video, if you learned from this video, if this is mind-blowing, then please hit that like button, smash it. Make sure you subscribe to my channel, hit that notification bell, put comments in the comment section, share this video, let me know what you think. ask me questions that I can answer, and that's about it. So thanks for joining me. Have a great day.